All right, guys, we're on a roll. Today we are talking about the distributive property. Distributive property. Here we go. Okay. Whoops, that would be helpful if you could actually see that, huh? So the distributive property. Again, these notes are in Canvas under the assignment, like with the Ed puzzle. So you could just click on that little hyperlink there and it will either allow you to download it to Google Drive or print out whatever you would like. Okay, so the distributive property is used to simplify the product, meaning multiplication, right? To simplify the product of a number and a sum or difference. So let's say, sounds great, right? Let's say we have A, and he is outside the parenthesis with B and C. Right. The distributive property means that we can take this fella out here, this A, and we can multiply him, distribute him to each of the terms within the parentheses. So that would look something like A times B, right? A times B plus, oops, I did that backwards, A times C. All right. And then the same thing works if it's a subtraction problem. So if I were to do B minus C and then A here on the outside, it doesn't matter if it's behind, you would still distribute it. So that would look like A times B minus A times C. Okay, Mrs. Black, that's great, but how? It always helps when we do it with some numbers, right? So let's do it with some numbers. We're going to go ahead and just take this 4 and we're going to distribute it, meaning he's going to go get multiplied with everything inside these parentheses. So first it's going to be 4 times x plus, well, I should probably put 4 in parentheses, 4 times 5. All right, well, 4 times x is simply 4x, and 4 times 5 is 20. And that would be my answer. This is an expression, guys. There's no equal sign, so it's just an expression, right? Because there's nothing else we can do with that. An equation would have an equal sign in it. All right, so let's do this again. Actually, why don't you guys try this one? Pause me for a sec. All right, hopefully you paused me and gave it a shot. I'm going to take this -3 and I'm going to distribute it to each of these terms. So I'm going to have a -3 times x minus a -3 times 4. I'm going to simplify that, excuse me, while I yawn. So, oops, wrong color. -3x minus -12. What happens when I have two negatives side by side? It becomes a positive. So this becomes -3x plus 12. All right, let's move along. Oh, shoot, there's a negative. Well, technically, there's a 1 right there. We just don't write it. So I'm going to take a -1 and I'm going to distribute it to each of these terms. So I have a -1 times 2x minus -1 times 5. All right, so I will do that part, -1 times 2x, -2x. And then a negative and a negative would become a positive. So this -5 with the minus in front of it would become just like this problem up here. Two negatives make a positive. And negative 2x plus 5. Okay, so box our answer. And now we come to this other one, which you guys should be old pros at. We're going to take this negative and we're going to distribute it to both of these terms. So I'm going to have a negative 1 again times negative 3x plus negative 1 times 6. All right, well, when I simplify this, I end up with a positive 3x. Negative 1 times negative 3 is positive 3. And a minus 6. So that is my answer. That's the distributive property. Okay, let's talk about square roots. All right, so squares, right? It's when you raise something to the second exponent. Let's say we have 3 squared. That is traditionally written as 3 times 3, right? 3 squared would be 3 times 3, which equals 9. The square root undoes whatever a square has done. So for a square root, I would take the square root of 9. You might hear me refer to it as rad 9. It's the same thing, radical 9, square root of 9. So if you hear me say that, that's just, it's a hard habit to break. Okay, so what that basically means is I'm separating the 9, or it's 2 perfect numbers that multiplied to it, and I'm seeing what they are. So in this case, it's a 3. And since it's a 3 repeating, my square root would be 3. All right, so let's write this out in layman's term. A square root of a number, a square root of a number, I'm using this as the number sign in addition to a hashtag, is a value that can be multiplied by itself to give the original number. Oh, itself is one word, huh? Itself to give the original number. Right? A value by it that can be multiplied by itself to give an original number. So say you had 2. 2 times 2 is 4. All right, or let's say we took 11. 11 times 11 is 121. So what we're doing here is we're looking and we're seeing, oh, are these both perfect squares? Was a number multiplied by itself to get that number? Yes, it was. So for this top one, it would be a 3 and a 3 over 49, which would be a 7 and a 7. We're taking that repeat out, which would make this 3 over 7 as our answer. Okay, the one thing you can never do is take the square root of a negative number. But because this negative is outside the square root, you are completely fine. If it's inside, you can't do it. There would be no solution. However, we can do negative, and we know that 64 is 8 times 8, and 121 is 11 times 11. So now we can tack on that negative sign on the outside and put it with the 8 over 11. All right, this time we're going to estimate the square root of 136. Well, I know the square root of 144 is 12. And I know the square root of 121 is 11. So the square root of 136 has to be in between there, right? But 136 is closer to 144, so we're going to make it a little bit bigger. We're going to say that it would be like 11.7. That's a little closer to 12 than it is 11, right? So what I did was it's between 11 and 12, but closer to 12. So we went closer to 12 with 11.7. Between 11 and 12, but closer to 12. All right, and then again, it wants us to estimate the square root of 54. So I know 8, the square root of 64 is 8. And I know 7, the square root of 49 is 7. Which number is 54 closest to? It's closest to 49. So I would say the square root of 54 is approximately a wiggly equal sign 7, and we're going to go closer to 7 this time. So I'm just going to say 7.3. So in this case, it's between 7 and 8, but closer to 7. So we go down a little bit closer to 7. All right, so that's it. The distributive property and square roots. All right, guys, I'll see you soon.